In 2012, a delegation of Native Inuit Elders from the Arctic traveled to NASA headquarters in Washington, D.C. to speak with officials about how the environment is impacting their communities. During the meeting, the elders shared their traditional knowledge and offered guidance on how to protect the environment and mitigate the effects of a changing planet. One of the elders, Angaangaq Angakkorsuaq, a shaman from Greenland, spoke about the importance of respecting nature and the need for humans to reconnect with the Earth. He emphasized that the Earth is a living being and that all life is connected, urging NASA to consider the impact of its space exploration programs on the environment. Another elder from the Aleutian Islands spoke about the impact of melting ice on the Arctic ecosystem and the traditional subsistence way of life. He warned that if the ice continues to melt at the current rate, it could have devastating consequences for the region's people and wildlife. The elders also emphasized the importance of indigenous knowledge in addressing the challenges posed by a changing world. They urged NASA to work with indigenous communities to develop sustainable solutions and to respect their traditional ways of life. The meeting was significant because it highlighted the importance of incorporating traditional knowledge into scientific research and decision-making processes. Indigenous peoples have lived in harmony with the natural environment for thousands of years and have developed a deep understanding of the land and its resources. By integrating this knowledge into scientific research, we can gain a more holistic understanding of the natural world and develop more effective solutions to environmental challenges. The Native Inuit Elders' visit to NASA also served as a reminder that a changing world is a global issue that affects us all. The melting of Arctic ice, caused largely by human activity, is contributing to more frequent extreme weather events and the loss of important habitats for wildlife. By working together and incorporating diverse perspectives, we can develop effective solutions to mitigate the effects of a changing Earth and protect our planet for future generations. As of right now, the visit of the Native Inuit Elders from the Arctic to NASA was a significant event that emphasized the importance of incorporating traditional knowledge into scientific research and decision-making processes. Their guidance and wisdom serve as a reminder of the need to protect the environment and respect the interconnectedness of all life on Earth. NASA, as one of the leading scientific organizations in the world, is actively engaged in studying and mitigating the effects of a changing Earth. The space agency has been monitoring Earth's atmosphere, oceans, and land surfaces for decades using a variety of tools, including satellites, airborne missions, and ground-based observations. NASA's Earth Science Division is dedicated to understanding the Earth as a system and the impacts of human activities on the planet's environment. One of the key ways NASA is combating these global issues is by studying greenhouse gases, such as carbon dioxide and methane, which trap heat in the Earth's atmosphere and contribute to rising temperatures. The agency's Orbiting Carbon Observatory mission, for example, is focused on measuring carbon dioxide concentrations in the atmosphere from space. This data is used to track the sources and sinks of carbon dioxide and to better understand the processes that control the Earth's carbon cycle. NASA is also involved in monitoring and studying the Earth's polar regions, which are particularly sensitive to changes around the planet. The agency's Operation Icebridge mission, for instance, is dedicated to measuring changes in the thickness and extent of Arctic and Antarctic sea ice using airborne observations. The agency's Gravity Recovery and Climate Experiment mission, on the other hand, uses twin satellites to monitor changes in ice sheets and glaciers, which contribute to sea level rise. In addition to studying the Earth's climate, NASA is also working on developing new technologies and strategies to mitigate the effects of a changing Earth. The agency's Innovative Partnerships program, for example, is focused on finding innovative solutions to environmental challenges and has revealed to scientists that the Earth is constantly changing and that these changes have a direct effect on everything across the planet. NASA is also working with industry and other partners to develop more efficient and sustainable technologies such as electric aircraft, advanced energy storage systems, and biofuels. Finally, NASA is playing a leading role in international efforts to address these issues and has said that these changes are now starting to directly affect people. As of right now, NASA is taking an active and multifaceted approach to combating these changes. The agency's research, technology development, education, and international collaboration efforts are critical components in the global effort to mitigate the effects of a changing planet and to create a more sustainable future for the planet. AI system detects strange signals of unknown origin. As our technology continues to evolve, so has the search for alien life, as scientists based at the University of Toronto have begun to employ the help of AI in the quest to find alternate life. An international research team has been conducting a search for extraterrestrial life in a more streamlined manner than we have seen before. Up until now, we have seen lots of work by astronomers being conducted via SETI, the search for extraterrestrial intelligence. This work, which has been ongoing for upwards of a century, with dedicated international research since the 1980s, has used an array of radio telescopes in order to detect what is known as a technosignature. This field of study involves the monitoring of electromagnetic radiation for signs, signals, and other similar indicators that there may be life out there on other planets. Despite this research being conducted from well-considered and ideally located facilities, there is a common issue presented in the human interaction. Often disturbances can be picked up from phones, television stations, and other challenging factors. And whilst these techniques are still employed, new techniques are being introduced too. In recent years, this research has taken a grand leap forward, as researchers based at the University of Toronto have begun to implement the use of artificial intelligence in this same vein of study to limit those same human-introduced issues. An algorithm has been designed to organize the data gathered from these telescopes, dividing the data into distinct categories, allowing for a differentiation between what is a real, genuine signal and what is interference. This process has been introduced to the AI through a method called machine learning. This is the system by which the computer system begins to develop its own intelligence. It's a complicated and arguably controversial process by which AI computer systems begin to learn how to effectively think and behave independently, in a way somewhat comparable to humans. In this context, machine learning will enable the researchers to pore through the relevant information with much greater ease, and with far quicker efficiency. This should make spotting patterns in such large data sets far simpler. Peter Ma, an undergraduate mathematics and physics student at the University of Toronto and first author of a research paper detailing this published in the Nature Astronomy academic journal, commented on the presence of interference in their observations. He explained that the difference is being able to distinguish between the radio signals from space to the uninteresting radio signals coming from down here on Earth. The team were able to effectively teach the AI to begin to sort and recognize these different signals by simulating the different varieties, showing the difference between signals that may be extraterrestrial and those that are deemed more likely to be human-generated. Prior to running these simulations, work had to go into selecting the machine learning algorithms, drawing comparisons between the precision, the statistical production of false positive rates, and then using these factors to select the aspects resulting in the most appropriate algorithm, which was eventually created by Ma. As it turns out, this new algorithm resulted in the discovery of 8 radio signals that have been deemed potential transmissions from extraterrestrial intelligence. Further analysis has seen they were sourced from 5 different stars, ranging between 30 and 90 light-years away. What is most exciting, though, is that this same data has been studied before, without the use of AI, and these signals were not discovered at all. While it is certainly a possibility that these signals could be sources sent from extraterrestrial life, and they follow the anticipated format, this doesn't automatically mean that that is what is being observed. Kepler 70b is hotter than our Sun. We have several methods that we can use to track down exoplanets using varying techniques and equipment. Some of these methods include relying on radial velocity, planetary transits, gravitational microlensing, and pulsar timing. These can all get the job done and clue us in to just where we might find an exoplanet lying, though some methods are easier to use and generally more reliable, namely using planetary transits. Whilst NASA's Transiting Exoplanet Survey satellite is perhaps the main satellite doing the job, it was by no means the first technology of its kind set up to track planetary transits. Back in 2009, NASA launched the now retired Kepler Space Telescope specifically to look for exoplanets roughly the same size as Earth. The telescope uses a photometer to assess how bright stars are. This can be helpful as when a star has regular dips in how bright it is, it can show a planet passing in front of the star in its orbit, indicating that there is indeed an exoplanet orbiting the star. Now, astronomers are able to take this research one step further and use the specific details and small changes in the light to figure out all sorts of information about the candidate planet, including the mass, the speed, the size, and the orbit. This is a useful process, and it is not foolproof as there are other occurrences that can result in the momentarily dimmed brightness of a star, such as sunspots or asteroids passing in front. Overall, the Kepler Space Telescope was a success, mapping out the location of 2,662 exoplanets during its lifetime, from 2009 until 2018. One of the systems confirmed to be found by the Kepler Space Telescope was Kepler 70b, a small planetary system. This had a subdwarf B star, Kepler 70, with two exoplanets, Kepler 70b and Kepler 70c, orbiting it. These exoplanets are both gas giants, not unlike Saturn or Jupiter in our own solar system. Of these two exoplanets, one has been discussed and spoken of much more frequently. We have tried to find conditions like Earth. We have found some far more extreme on Kepler 70b. Let us delve into why Kepler 70b has conditions quite as extreme as it does. The answer lies in the exoplanet's past. The Kepler 70 star was once a main sequence star, albeit 18.4 million years ago as it turned into a red giant stage of the star life cycle. The star pulled the two planets in, engulfing them, swallowing them. We do not know how the two exoplanets somehow managed to survive this experience or whether or not they had an impact upon the star itself. What we do know, however, is that somehow, against all odds, there are two exoplanets that have had any sort of atmosphere they might have once had torn away and are left as two burning hot cores. The sky-high temperatures of Kepler 70b, due to the lack of atmosphere, the incredibly close distance to its host star Kepler 70, the hot conditions of Kepler 70 itself, and its orbit taking just 345 minutes compared to Earth's 365 days, all make it clear that there is not likely life lurking on this exoplanet. The conditions of this exoplanet are fascinating. Exoplanets might only seem interesting when they may contain life. To gain more of an insight into how the different planets and stars without our universe has formed is invaluable information. Planet HD 189733b. As we mentioned previously, there are many ways to detect exoplanets and keep an eye out for them in the universe. Kepler 70b was found using the Kepler Space Telescope and planet transiting observations. Other techniques have proved just as successful in tracking down exoplanets. Planet HD 189733b is a transiting exoplanet found in 2005. This discovery made use of real-time radial velocity measurements, which were able to highlight the Rossiter-McLaughlin effect in action. The Rossiter-McLaughlin effect refers to what happens when an object moves in front of a star, the same concept that allowed us to measure the dips in brightness on Kepler. The team also detected the exoplanet more accurately following the initial discovery using Doppler spectroscopy, often called by its much more fun name, the wobble method. This is an indirect method of observation, where astronomers look at the shifts in the star the planet is orbiting to find out more about the exoplanet itself. What is more unique about HD 189733b is its strong infrared thermal emission. This is the first exoplanet to have ever had a thermal map made of it. Additionally, this is the first planet to have had its color confirmed by two different techniques, with the blue hue being confirmed in 2013. Besides becoming the subject to all these brand new techniques, HD 189733b had a lot more to it than being a guinea pig. To us here on Earth, the nice pretty blue colour looks somewhat similar to Earth, though the blue skies we know in our home are nowhere to be seen here. Winds can blow up to 7 times the speed of sound. According to NASA, if a human did somehow reach this exoplanet, the winds move with such danger and violence that they would be caught and whisked into a spiral. If you thought this was bad, wait until you hear about the rain. NASA has some extreme imagery, describing this as death by 1,000 cuts. The rain is practically made of glass, and these harsh conditions would not let anyone out alive. The pretty blue color here on Earth comes from a reflection of our gorgeous tropical oceans. On HD 189733b, it is from the silicate heavy clouds in a dangerous atmosphere. The more research we do, the scarier places we find and unravel. Stars may be forming 10 times faster than first thought. Whilst we do know a fair bit about the complicated life cycle of a star, whether it becomes a supernova, a white dwarf, or one of plenty of other options, there is still a great deal of mystery, especially right at the start. We know that the initial time it takes for the star to begin to form, the gestation period, can be incredibly long, taking up to millions of years, but research published in early 2022 has revealed that this process could be happening at a much quicker pace than previously thought. A research team based in China used the 500-meter aperture spherical telescope, also known as FAST, to observe the inside of a molecular cloud. A molecular cloud is rich in gas and dust, meaning that stars are able to form within them. These wispy clouds have low temperatures and high densities, meaning that if a star is being formed, it must occur within a molecular cloud. The particular cloud observed by this team of astronomers was LINS 1544, a giant gas cloud just 450 light-years away, found within the Taurus constellation. Some scientists have begun to speculate that a star may be just about to be produced at this cloud. It has become a fascinating point of observation. Studying the very start of a star is incredibly useful information, and it begins with knowing about the molecular clouds. As we mentioned previously, the high densities and low temperatures form the perfect environment for the stars. The clouds are pulled together by gravity, bringing the hydrogen gas close, meaning a pre-stellar core can be formed. The densities of these cores are so high that they often collapse, folding in on themselves and starting a nuclear fusion process. The magnetic forces then hold the matter still, slowing the process down significantly. After the gas cloud, the star evolves into a stellar embryo, an incredibly slow portion of the process, helped along by the gravity and magnetic forces already in the process. The strange part is that in LINS 1544, this slow process that we know can take so long did not happen. Instead, hundreds of stars were seen to be in the early stages of their formation and developing 10 times quicker than what was anticipated. Scientists have begun to speculate why, with some suggesting this difference is due to weak magnetic forces, that the magnetic field in between the densest portion of the gas cloud and the edges of the cloud was revealed to be 13 times weaker than once thought. FAST, the telescope making these observations, is only able to measure the middle region of the cloud, which, whilst this does contain one of the most significant portions of information, plenty more aspects are also incredibly useful. Is there a missing or less accurate piece of the puzzle that, if we found, could clear up this picture? If we can observe similar patterns in the magnetic fields of other gas clouds, then this research would have a significant impact upon how we view star formation and the pace of this process. But what do you make of these recent discoveries? Be sure to let us know your thoughts in the comment section below and help us grow this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.